Hi everybody, I'm Keith. I'm here today with my best friend Bob, and this is Shop Talk.
Hey guys.
Today we are going to talk about the things you need to be aware of, the parameters. I can't think of the special word.
You know, the designs of, or how something's made. I mean,
yeah.
Really, what are the features that make a CNC work?
Yeah, we know most, if you're shopping for a CNC, how do you make the decision to buy the best CNC that's right for you?
Absolutely.
Okay, so I've come up with a list. Bob and I have been working on one for about a week now of the different elements that make up the design of the different machines that we make, and you can use these as to help you take a look at what other folks are making to see if you're happy with what they're doing. We want you to get the machine you want. Absolutely. Not just get something because we build it. But one of the things we talked about a few weeks ago is a lot of folks, the first thing you're going to look at when you're looking at a CNC is the material that it's made of. Yeah. And it's going to be either stamped steel or milled aluminum or in our case,
extruded aluminum.
Extruded.
Yeah.
Well, okay. And then of course you got us with plywood, but we talked about it.
Yeah.
And how you can. Well, I'll let you mention that a little bit.
Well, I mean, for sure. I mean, wood is better than paper. Aluminum is better than wood, and steel is better than aluminum. As far as the material stiffness. I mean, you can look these values up. However, as we talked about, I mean, there's a lot that goes into design too. I mean, I could build a steel CNC router that wasn't rigid at all, right? Or I could build a paper one, or maybe cardboard, that had some rigidity. So it really, I mean, there's a lot going on there. But the bottom line is there are good reasons to buy. I mean, I have a Bridgeport CNC Series 1. It's 3,500 pounds. It sits in my shop, and
it doesn't go anywhere.
It doesn't have any flex. I mean, I don't worry about the flex of the machine. I worry about the flex of the bit that I'm using, and I've broken some bits. So yeah, there's that kind of machine, and then there's less expensive hobby machines. Like, I mean, the E3 and the E4 is an entry-level machine. It's a good machine for what it's designed for. So yeah, so let's go over, what are the designs that we can talk about to help clear it up for our customers.
Well,
understand.
One of the things people see right away when you're looking at ads is people will talk about the size of the machine.
Yeah.
And so what's the difference between the size of the machine and the cutting area of a machine?
Oh, good. I get to talk about my Bridgeport again.
Okay.
So it's 7 feet tall. I think it's 4 foot by 4 foot, 3,500 pounds, and the cutting area is 12 by 18 by 3. So it's a huge difference, right? So yeah, I mean, you just need to understand. I mean, you need to know the overall size, right? So it'll fit in your shop. But if somebody says it's the overall size, then that's just the size of the machine. What most people are interested in, or at least what I'm interested in when I buy a machine, is what is the cutting area? How big of a piece of material can I put in? So, I mean, the technical term would be volume, although most of the time we say area. It's this length by this high, right? So the area would be the length and the width, and then the height would actually make it a volume, right? But that would be the big thing. So yeah, we advertise our machines as the cutting area. So that's the area that they will cut. Now, if you're looking for the size, I think our assembly manual has the footprints, or how large they are,
right,
for those that want to make enclosures.
And the biggest thing, guys, is to understand what is it you want to fabricate. Because if you're thinking about making little plaques, and you're wanting to go 1 foot or 12 inches by 18 or smaller, then that affects the kind of size. You don't need to buy monstrous machines to little material.
As a matter of fact, from an engineering point of view, a little machine is a lot easier to make rigid, right? Because of the math. The longer it gets, the harder it is to design something that's rigid. As a matter of fact, that's why you won't see a lot of high Z machines that have a lot of Z travel up and down, is because the engineering and the materials that it would take to make that rigid enough to work would be extreme. It would be like the Bridgeport mill.
Right. Okay. So you talk about the size, And then another thing you'll run into is people will be talking about spindles versus routers.
Right.
And there seems to be an implication that a spindle's better than a router.
Yeah, you know, I guess it depends on what you're looking for. So I guess we could talk about them. So we use the 660 mostly because it's simple and cost effective. It's a brush motor.
660 what?
DeWalt router.
Oh,
sorry.
okay.
Yeah. The one that we use for our E-Series or the E3 and the E4, right? It's really because it's a cost-effective solution, and this is our entry-level machine. Now, we do have some kits that you can put the DeWalt 660 or the Makita RT0701C.
God, you memorize that.
Yeah,
it's unbelievable. That's like somebody's name.
Okay, whatever. But anyway, and then also you have what they call a quiet spindle, which is really a big DC motor, and then they have real. I say real, maybe that's not the right word, but they have three-phase spindles that are brushless. Some of them are air-cooled, some of them are water-cooled. So, I mean, it goes from probably the most inexpensive and less features all the way up to, you know, the water-cooled three-phase with your variable frequency drive VFD. So let's start from the most expensive. First of all, they make them air-cooled and water-cooled. I would never do a water-cooled one because it's just another circuit, and I'm a simple and cost-effective kind of guy, right? So for me, the water-cooled is not needed. Now, if I was running a Mazak or an industrial machine where I had coolant stuff, yeah, it's a way to keep the motor cool.
Well, I understand that, but is there an inherent benefit on a small machine? Because we're talking about hobby entry-level machines.
You know, I can't see that you would drive a hobby machine hard enough to where an air-cooled spindle wouldn't work.
Okay.
Their biggest advantage in my mind is they're brushless, they're three-phase instead of single-phase or 220, which is still single-phase, but we can talk about that for a brief moment. But they're quiet and they're three-phase. So the quiet obviously is easy to understand. The brushless means that they don't have brushes to wear out, so you don't have to replace them. But what is the 110 versus 220 versus the 440 or the three-phase? In simple terms, I would say that a single-phase or a 110 motor, you get one person making it turn. Whereas in 220, maybe you get two people, right? Because you get 2 bumps per rev or 2 bumps per cycle. And then the three-phase, right, you would get 3 people making it turn. So you get more of a constant torque, and it's a lot more efficient because all of those people aren't working very hard, right, when there's a lot of them, whereas the one person gets killing him. So I mean, that's as simple as I can do it, you know, for non-electrical. I got an old boss that is going to be laughing right now because we've talked about single phase versus three phase. But
well, he doesn't understand what it is working with me.
Yeah.
And I need simple explanations so that they.
Well, that was as simple as I can get. And if you're an electrician and don't laugh too hard at me because we could go into the phase diagrams and stuff. But
let's not go there.
We won't do that here today.
So, but we're using a DeWalt 660. Really, it's a cutout tool more than even a designed specifically to be a router. But you've got great bearings.
Yeah.
You got 30,000 RPM.
Yeah.
And it's a workhouse.
Yeah, it is. And actually, when we first started doing this router, we were trying to do it with a Dremel type of tool. And as a matter of fact, I was really bummed because the Dremel lasted about a day and a half, and it was like, okay, well, this is a bad Dremel, so you put another one in and you got another day and a half, and it's like, well, this thing is never going to fly. And I used to work construction back before I became an engineer, right? And I had one of these old things, and I started tearing it apart, and it looked really good for a CNC, and I thought, I wonder if I could do that. And with all the testing that we did early on, it's a very good CNC. It's noisy, it's loud, but it's a really good choice. As long as you keep the brushes clean,
keep the brushes clean, but the biggest thing too is it keeps the cost down.
Yeah, absolutely. Yeah. Now, I think most of you know. If you don't, you can look at our store. We do have some other mounts that you can add. The fancier routers or the trim routers, the DeWalt 660? 611, thank you. Yeah. Or the Makita.
RT0701.
You're looking. See,
you got it.
But anyway,
I'll never memorize.
So you can look those up. And for our newer router, we're going to go with those two. And I don't know that we're going to offer a spindle but we may offer you the DXF files for the pieces that you would need to make a different size hole. So it really isn't a matter that it's complicated. It's just a matter of how many boxes do we want to pack up and send out the door. So
we've talked about the cutting area. We've talked about the spindle. That's kind of RPMs is in that thing too with the spindle. What about the brains of the machine, the processor? What's making it operate? Now with the E3 and all the way to the new KL series, we are staying with Arduino. What'd you say, version 1, right?
Well, it's the Arduino Uno is the microprocessor, and we run Gerbil 1.1 firmware, which I would say that most CNCs you find out there on the market, or the homemade ones that that are under around $2,000, they're all going to run the same firmware. Maybe different iterations of it. As a matter of fact, we just upgraded to the latest. Sonny wrote a self-squaring firmware for our machines, and it's out there for all the other machines too, but what it actually does is, on a gantry, you can understand if one racks, or if it's racked a little bit, you could cut out a square. So this, when you actually home it, it squares it up, and you can make those adjustments to your home switch to make sure that it stays square. But so yeah, we use the Gerbil firmware. Now there's others out there. I mean, you'll see, like the Mach 3 or Mach 4, I think they're up to now, and the Linux CNC, which I really like for your bigger machines. You could use those. You could convert the machine to that. The problem is they're a parallel port interface, and you're going to have to find an old desktop, or enough about computers to get you a desktop and slip one of those PCI cards in there, and then do all the setup you would need. They have more features, but those features are probably more for the advanced users, or for people that do a lot of machining in steel, and that's not what our machines do.
Like tool changes.
Tool changes, pecking cycles, so like for drilling. And you can write macros in them, so that complicated code where you're doing the same sets of types of holes, but you're doing it in different locations. It just has, it takes advantage of a larger set of G codes and M codes.
Right.
And but again, for your hobbyist, or for a person that's really serious about CNC router type, Gerbil firmware does everything that you're going to need it to do. So and it's a USB interface. And there's G-code senders, of which we recommend the universal G-code sender that Will writes. But yeah, so yeah, that's the reason why we do that. So.
Okay, well that's the brains of the thing.
Yeah.
Okay, now how about the drive components? Because you've got there's some way that thing is moving up and down on the Z-axis and back and forth on the Y and X. Okay. So we've got on our machine out there, we've got a rack and pinion.
On one of our machines, yes.
Well, yes, and on the E3, E4, we're using belts.
Yes.
And they're just running over sprockets, right?
Pulleys, timing pulleys is what they call them.
And then and then we've got Bell Everman coming out on the KL series.
Yeah.
So what can we say that people need to be aware of when it comes to the drive components?
That's another lengthy discussion, so I think we've probably gone long enough for this one. So I tell you what, why don't we make this a series, and next, guys...
I wanted to hear.
You will.
Oh.
Next week.
Next time.
So we're going to go ahead. Can we do that, Kristen? Can we make a series, and we'll just pick up this discussion?
She doesn't have a choice.
If I get a raise, we can make a series.
You just got a raise.
You got a monster raise.
Golly.
Yeah.
Greedy employees.
I'm thinking about a pay cut.
There we go. I like that idea better.
Me too.
Then give us a raise.
Yeah.
Anyway, so we're going to we'll go ahead and do an intro for next week, and we'll just start up with this discussion again.
All right.
All right. See
Only
you guys.
because Bob said so. See you next time.
Next time.